Okay, so we're going to look at shaping the course. We're going to look at calculating a course to steer. And a way we can do this is by conceptualizing how it would be in a river where we've got tide flowing across and we're trying to get from point A to point B. So we're going to go straight across that river. If we point the boat at point B, then you can see that the boat will get pushed off course by the tide and you will end up at the green mark there. So clearly we need to steer up into the tide. We need to create a course to steer. And if we point the boat at the red mark, then we will stay on our intended course over the ground from A to B, our ground track, we call that. So on a chart, we would mark that line from A to B, and we put 2 arrowheads on it. The way to remember that is that you keep 2 feet on the ground. So 2 arrows on a ground track in chart work. The way the boat is pointing is the course to steer, the heading, which we are pointing towards the red mark there, and that's a water track. Now, you only dip your foot in the water, you dip 1 foot in the water because it might be cold. And that's how we remember to put 1 arrow on our water track. When we're doing our chart work, the course to steer will have 1 arrow on it. Dip 1 foot in the water because it might be cold, but keep 2 feet on the ground. So that's our course to steer. In a river, it's easily conceptualized. And we'll have a look at what happens in open water. We'll also have a look at what happens to our boat speed. If we're doing a speed through the water of 10 knots, then the boat would go in any direction at 10 miles per hour. If we went with the tide, you can see that it would be doing 13 knots, 13 miles per hour, 13 nautical miles per hour. And if we went directly against the tide, it would only be doing 7 knots, 7 nautical miles per hour. So that's easy in a straight line, and we're going to look at how we can do that in open water. So this is an easy method that you will use for calculating a course to steer in open water. You'll be giving a start waypoint, point A, and a destination waypoint, point B, and you'll plot those on your charts and have a look at the distance between the two. When you've been given, or you know, the speed of the boat, you can estimate roughly how long that's going to take and decide how much of the tidal window that you're going to be using. So in this example, that's a whole hour of tide, and we've been given the tidal information there. It's been obtained from a tidal diamond called Tidal Diamond K, which would be on the chart near the area that we were navigating in. And that gives us the set, or the direction, that the tide is likely to push the boat in, and the drift, the rate at which the tide would push the boat over the ground. And we will look at calculating those in other videos. So for the time being, we've been given the set of 120 degrees true and the drift of 3.0 knots. So that's enough to move the boat 3 nautical miles per hour in a direction of 120 degrees true. So that's a known quantity. The first thing we're going to do is plot our intended ground track, just like we did if we were crossing a river going from point A to point B. That's our intended track along the ground with 2 arrows on it. You'll notice that, importantly, we've extended that line, and that's just going to give us a bit of room to work out the course to steer. The idea is that we're going to stay on the line from A to B, and if we end up with a vector that takes us past point B, we would simply stop when we got to point B. So we're looking to work out the course to steer that keeps us on the line from A to B. Back to that known vector, if you imagine that A to B is some 8 or 9 miles, then A to C would be the effect that the tide would have during that hour. It would push us at a direction of 120 degrees true on the chart for 3 miles, 3 nautical miles. So we could plot that from the start point. We could think about if our boat was at point A and we did nothing, after an hour we'd be at point C. Now, given our boat speed, we can then calculate from the end of the tidal vector, the point C there, where 1 hour of our boat speed would take us. So in this example, our boat speed is 10 knots, so the line C to D is 10 miles long. And you'll notice that it intersects the line A to B at point D. So that is our course to steer. The line C to D is our course to steer, our water track. That is to say that if we point the boat in the direction of C to D, that will take us from point A to point D and keep us on the line that goes from A to B and also to D. As we mentioned, we would stop when we got to point B. And we'd know when to stop by working out our speed over the ground and the distance to the waypoint. Thinking about our speed, distance, time triangle, then the distance to the waypoint divided by the speed over the ground will give us the time in hours, which if we multiplied by 60 would give us the time in minutes. So just looking at that, then we have to measure A to B. How far is it? A to B, that's the distance to the waypoint. So we measure that distance. And what about our speed over the ground? Well, we said that this process had taken 1 hour. So where did we start? We started at A. Where did we finish? We finished at D. And that took us 1 hour. In this example, we used a whole hour of tide and we used a whole hour of the boat speed, our 10 knots. So the distance that we've travelled from A to D is the distance we've travelled in 1 hour. We measure it and it comes out as 12 miles. Then our speed over the ground is 12 miles per hour, 12 knots. And that gives us the time to get to point B as the distance to the waypoint divided by our speed over the ground, which is 8 miles divided by 12 knots multiplied by 60, and that gives us 40 minutes.